Hello everyone, welcome back once again. So today we will develop a program for multiplication of two matrices. Okay, so before going ahead, let us understand how to perform the operations. So when we multiply matrices, for example, we have these two matrices in front of us, and this is a 3 by 3 matrix. There are 3 rows, 3 columns, and this is a 3 by 2 matrix, that is 3 rows and 2 columns. So how we are going to perform the operation is we are going to consider. Okay, before we go ahead, the first condition that we have for multiplying two matrices is the number of columns of the first matrix. Okay, the number of columns, like these are 3 columns over here. So the number of columns of the first matrix should be equal to the number of rows of the second matrix. So if there are 3 columns in the first matrix, so it should be equal to the number of rows of the second matrix. So you can see there are 3 columns, and so there are 3 rows for the second matrix. Okay, now this is the basic condition. Now how we are going to perform the matrix multiplication is first we are going to consider the first row and first column. So I've just highlighted this into red, so you can see first row and first column, and then what we are going to do is multiply the position first row first column, that is 2 of the first matrix. I will multiply that with the first row first column, that is 56. So if you see the the operation that we're going to perform is 2 into 56, and then we're going to add that with another product, that is 34. So we will move to the next column of the first matrix and the next row of the second matrix. So 34 into 6. Okay, and again we will add that with 5 into 22, as you can see over here, and this answer, this operation, we are going to store in the third matrix in first row first column. Okay, and once we perform this operation, we are going to move to the second column of the second matrix. So you can see over here, so we have moved to the second column, so first row second column, and then you can will perform the same operation, that is 2 into 7. Okay, plus 34 into 42 and 5 into 10, and that is we are going to store in the first row second column of the third matrix. After this, what we are going to do is we're going to come back to the first column of the second matrix, and this will move to the second row, just like this. So this is second row of the first matrix, and the first column back again to the second matrix. So first second row first column, second row and second column. This is how the things are going to work. So this will perform, as you can see, 64 into 56, and that we will add to 4 into 6 and then 42 into 22. Okay, so 67 into 56, 4 into 6 and 42 into 2. And then we will move to the second column, and you can see the answer over here. That is how we are going to perform the operation, that is 67 into 7 over here, then 4 into 42, and then 42 into 10, right? And then at the last, we are going to move to the last row and the first column, and the last row and the second column, and you can see 7 into 56 plus 12 into 6, 22 into 22. You can see over here, and then the last operation, 7 into 7, and then 12 into 42 and 22 into 10. Okay, and this is the answer that we are going to have it over here. So the answer, if you see, this is what we are going to get in the third matrix. So this is how we are going to perform the operation, and always remember the answer that we get, the third matrix that we generate will always have the lesser dimension. Okay, for example, when we multiply two matrices, this is having the lesser dimension. This is 3 by 2 and this is 3 by 3. So there are more elements, there are less elements, but the answer we have is 3 by 2. Okay, so whichever is less dimension, we will have that answer over here. That is the dimension the third matrix will have. Okay, so this is what we are going to do. Now let us just start the coding, and to make the things to fast up the things, I've just have this code in front of you. I've already typed the code. Okay, and just let us understand what exactly I've done over here. Now in this code I've just said okay, this is for the first matrix, and then we are taking number of rows and number of columns for the first matrix. Okay, so number of rows and number of columns, these are simple variables, you can see. And then we have declared some m1, m2 and m3 which are empty list. Okay, and then what we have done is okay, then what we have done over here, this particular thing is we have created a two-dimensional list over here. So this creates a two-dimensional list. So if you're not aware how to create a two-dimensional list for storing the elements of a matrix, I have one of my videos where I have created two-dimensional list and I have explained this, how this works like. Okay, so you can go back to that video if you're not aware and then come back to this video. And so this is the first two-dimensional list that I created for storing the elements of the first matrix. And then for the second matrix, what I'm doing is I'm only accepting the number of columns. Okay, I'm not accepting the number of rows. Now this is because the number of columns of the first matrix will be equal to the number of rows of the second matrix. So whatever the columns I enter for the first matrix will become the number of rows for the second matrix, isn't it? So all I have to do is accept the number of columns. The columns can vary for the second matrix. Okay, just like in this example, you can see there were 3 columns, and for here there are only 2 columns, isn't it? So I have to only accept the number of columns. Then that I stored into cols2. This is another variable. And then I created a two-dimensional list for the second matrix. Then again with the same thing I used, and I just said M3. So I created a third matrix also, a two-dimensional list, so that we can store the elements. Okay, just to show you how things are going to work, I'm displayed this empty matrices over here and just putting this entire thing under, okay, making that as a string, and so that, okay, we just work till over here. Okay, if I run this code, you can see it will ask for the number of rows. If I say 2 and 3, and the number of columns for second matrix, if I say as 3, so you can see this is the first matrix that got generated and we stored zeros into it. This is the second matrix. Now you can see there are 1, 2, 3. There are 3 columns, so there are 1, 2, 3. So for the second matrix we have 3 rows, and the columns that I enter is 3 for the second matrix. So we have 3 columns. Now this is the third matrix that we have generated. Okay, over here maybe the answer that we are going to get is 2 by 3, but then we have the third matrix as 3 by 3, but that's okay. We will only display the first 2 rows. Okay, so this is how we are going to work. So these are the empty, there are 3 matrices in front of you which we can say are empty matrices, since we have just assigned zeros. Okay, we have just stored zeros into it. Okay, so this is how it is going to work. Now I just remove this, and now what we are doing over here is we are accepting the elements. So okay, this is the code. We are accepting elements in the first matrix by using a nested loop, and for I and j. So this runs for the number of rows and this runs for the number of columns. So this is like the variables of the first matrix, rows and columns. And then I'm using an input method, input function, and I'm just saying this, enter the value at row, and I'm saying str of I plus 1. So I will be initially 0, so 0 plus 1. So it will say actually enter the value at row 1 plus col 1. So this is how the message will get displayed, and just we will keep on storing 0, 0, that is first row first column, and then j will become 1, so 0 and 1, first row second column. So this is how we are going to store the elements in the first matrix. Okay, similarly for the second matrix, but there is a bit difference over here is I'm running for the I in range is for cols. Now this is because the number of columns of the first matrix will be equal to the number of rows of the second matrix. So I need to use this cols, and this is cols2, which is the number of columns for the second matrix, and I'm storing that elements in the second matrix. Then okay, what I'm doing is I'm just displaying them. Okay, I'm just displaying these matrices over here. Okay, it is not necessary that I need this code, but just for for you to understand, we are just displaying these matrices over here. This is basically where we are actually performing the operation. Okay, this code is where we are actually performing the operation. So we need a nested, there are three nested loops. There is a I loop, there is a j loop, and there is a k loop. The I loop should run for the number of rows of the first matrix. Okay, j runs for the number of calls, that is of the second matrix, number of columns of the second matrix. Okay, this is where the things are important. And then the k loop again runs for the number of calls of the first matrix. So this is very, very important. If you interchange this or don't use it properly, then we will not have the result displayed properly. In fact, the calculations won't be done properly. Okay, so this is very, very important. Okay, I know there are many things already, there are many examples available on the internet, but all that examples that I've seen is where we have already three matrices predefined over here, and then they are performing the operation. But over here we are accepting rows and columns for the user, from the user, and then according to that we are creating the matrices and then performing the operations. Okay, so this is so important that I'm using total is equal to 0, and I'll just multiply this element and store it in total. So this is like every product will get added, isn't it? This is what we want. If we go over here, so every product, then we want to add to the next product, isn't it? The same thing I'm doing it over here. So this is the same thing. 0, initially it will be 0, so 0 plus then the product, and then it will get stored in total, and again that total will get added to the next product, and then we are storing that product in m of I and j. So these are the index values, as you might be aware of if you are aware how a list works. So these are the index values, how we are accessing the elements from the nested list or the matrix. Okay, and then we are actually displaying the result, that is m3 over here. Okay, so if you run this, let us run this now and give some inputs, like maybe there are 2 rows and 3 columns. Second matrix, I will say there are 3 columns, and this is the matrix that got generated over here. It's okay. Now you can see the message that I got is enter the value at row 1 and call 1. So if I give 1, I'll give some simple 1-digit numbers. Then I'm saying row 1 call 2. Now there are 2 rows and 3 columns. Okay, so 2, then there are, okay, first row, first column, first row, second column, first row, third column, and then you can see second row, first column, isn't it? Give some simple numbers. That's it. So this is where I accepted the elements in the first matrix and I stored them. Okay, then for the second matrix it is saying, now understand that the number of rows are 3, the number of columns for the first matrix were 3, so this should have 3 rows. So let us see if it is working. This is the first row, I am entering the elements, there are 3 columns. Okay, now the second row, and you can see over here that is the third row, isn't it? And then I'll store the numbers, and here it is. This is the first matrix, this is the second matrix, and this is the result that we have. Okay, let us run and give some another input. Let us give some another input. Okay, there may be 3 rows and 2 columns, and over here I gave 3 columns. So you can see over here this is like 3 rows, 2 columns, first matrix, and the second matrix we have 3 columns and the number of rows are 2. That is because we have 2 columns in the first matrix, and then this is the result. Okay, now let us give some numbers over here. Okay, let us give some numbers. That is 4, 5. Okay, just I gave some wrong input. Okay, let us run this again. That is 2 rows, 3 columns, and over here there are 2 columns. Okay, so you can see now there are 2 rows and 3 columns, and there are 2 columns for the second matrix, and number of rows are 3. You can see the number of columns for the first matrix was 3, so we have 3 rows. Now let us give the numbers. I'll just give some simple numbers, and this is the second matrix. Okay, and here we have the answer. This is the first matrix, this is the second matrix, and I've just displayed the list over here. the innermost list. If you can understand this code, I'm just using one index because I just want to display the list that we have inside this outermost list. Okay, if you want, you can use a nested loop I and j and display every element. Even that you can do it. Okay, so this is the entire program of how you're going to do the matrix multiplication. Okay, so I hope you have understood this tutorial. See you next time. Bye for now.